Hi, we're the Bridge Babes. My name is Sarah Lynn, and I'm studying civil engineering.
My name is Mohammed Alqahtani and I'm studying computer science.
My name is Abdullah Albokhari and I'm studying aerospace engineering.
And I'm Mackowsky, and I'm also studying civil engineering.
In our Collapsible Bridge project, we used the engineering design cycle to ensure a systematic and effective way to problem solving. And the first step was to ask. In this step, we addressed the constraints and requirements for our project. Our bridge design had multiple constraints, which were as follows. The bridge must support 40 pounds before it reaches failure. Must also fit into a 1 cubic foot box, span a gap of 5 feet, and be at least 1 inch wide. The design must be easily assembled in no longer than a minute. PVC or any type of plastic pipes may not be used, and the budget must not exceed $40.
In the research step of our project, we mainly focused on the arch bridge because of how we wanted our bridge to collapse. And after further research, we found that the triangle arch is the ideal form of arch bridge for a point load due to the line of thrust. And we also looked into magnets with how the magnetic force changes with magnets against magnets versus magnets against steel. And from there, we calculated the magnetic force needed for specific angles of our bridge. And in our imagining stage, we just started sketching some ideas about how we wanted to join the pieces together to make sure it collapses and we keep under budget. You can see that we mostly stayed with our initial sketches with our hinges and the magnets attaching the feet and also the pegs joining the pieces.
In the planning phase, we started 3D modeling based on the information we gathered last step, and we obtained the materials that we needed to build our bridge. Then we started work on the materials to adjust the bridge design to our constraints.
After finishing the planning part, we started the creation, highlighting the challenges we encountered and how we overcame them. Um, First, we faced a challenge with high demand items like hinges and latches. Our solution, we improvised with connectors and hinges. The second challenge that we faced is precision was another issue. Imprecise drilling led to crooked pieces and instability. To tackle this, we color-coded pieces and used wedges for stability. Unfortunately, wear was inevitable with the hinges and wood loosening over testing time. Our remedy involved using wood glue, fresh dowels for testing, and tightening hinges. Lastly, the lack of specific testing details threw us off, unfortunately, resulting in a 4 pound miscollaboration. Despite these challenges, our adaptability and problem solving skills ensured the success of our project.
So here you can see some images of our testing. We use the same apparatus as the testing would be done on FEDD design day, just consisting of placing a weight at the top of the bridge and testing the collapse point and making sure we adjust any kinks that we had, and that will lead us into our improvements. So main design changes, including switching from a circular arch to a triangular arch bridge, which would make the calculations of how exactly the bridge would calculate at what point easier. We also changed the line of thrust from the circular arch to a triangular arch because there's a weak point in the circular arch that allowed the bridge to collapse in a way that would not be able to calculate the pinpoint when we want it to collapse. We also reduced some weight in the bridge by drilling holes in each of the individual pieces, and we put leg supports that you will see in the next CAD model that will prevent the bridge from swaying back and forth. We switched from rope to cable, and then we switched from cable to rope, and then rope to chain to prevent the slack and give that would prevent any stretching on that apparatus from the magnets, to make sure the magnets have the exact point of collapse. And we also color coordinated the assembly, as Mohammed previously mentioned, to make sure the assembly went as smoothly as possible. This is the next line. So in the video shown here, our bridge supported 44 pounds at design day, and it weighed about 8 pounds. We were able to assemble it in 47 seconds. So we mainly hit all the points we wanted to, just a little bit off here and there, as we unfortunately did not take into account the calculation of the bucket's weight. And then here is a poster that we used at the FEDD design day, reiterating a lot of the points we'll make in this presentation to our judges.
So here we have some advices for the incoming freshmen. First, time management. Try to begin early by establishing a comprehensive timeline. Stick to this timeline to ensure progress. Also, the research is very important. Try to conduct a thorough research and try to make it relevant so you can take the benefit from the solutions if you face any problem. Review the constraints in detail. Make sure to hit all the points in research and testing. The final and important point is communication. Start communicating early and keep it consistent within the group. Set up weekly meeting that fits everyone's schedule. And thank you so much for listening.